Alright, let's take a look at section 2.6 here, where we're looking at the graphs of y equals k over x and y equals k over x squared. So both of these are inverse variation graphs. These are two graphs that you're going to have to be very familiar with in terms of their properties, what they look like, what their graphs look like, the names, etc. And let's just take a few minutes to kind of go through some of that. Now, before we go through kind of the properties of it, let's just take a look at activity 1 from your book. So on page 106 in your book you have this activity, and what I want to do is I want to look at the graph of y equals 10 over x, and let's do some investigation. I'm going to go pretty close to this right here, and just kind of, you might want to do the same with me. I'm going to do it in decimals, so you want to open up a decimals graph and you can plot the function f of x equals 10 over x. And what I want to do is I want to kind of look at what happens. So you'll notice that we have two branches here. We have a branch over here in the first quadrant and a second branch over here in the third quadrant. Once again, our quadrants are 1, 2, 3, and 4. So as we look at things, it appears that one branch stays completely in quadrant 1 and one stays completely in quadrant 3. And let's take a look at how that works. What I'm going to do is I'm going to zoom out a little bit, and then I'm just going to trace along this one branch. And you'll notice as x gets bigger and bigger, it's getting closer and closer to the y-axis, but it's never actually getting there. In fact, I'm going to go way out here. I'm going to go out to, I don't know, maybe 200, and let's see where we're at. It looks like it's kind of basically the same as the y-axis at that point. But if I zoom way in on that, and I'm just kind of rolling in with my mouse, boy, it still looks like it's really darn close. But as I get really close, you can start seeing, wow, there is some separation there. Well, let's just put our point on there, and you'll notice that way out here at 200, it's not 0 yet. In fact, it's never going to be 0. It will continue to get closer and closer and closer to 0, but it will never touch it. So if I think about the answer to step 2 in that activity, the answer is the graph will approach 0, but it will never touch it. Alright, step 3 asked us to start on the left-hand side of x equals 0. In other words, the negative x values, and continue to decrease or go away from 0 and see what happens. So let's do that. Let's take a look at our graph again, and I'm going to go zoom back right to that starting point that we were at. So if you just home, it will do that. Now what I'm going to do is I'm going to do the same thing. So now I'm over here, I'm in my negative x values, and as it get more and more negative, once again you'll notice it's doing the same thing. It's approaching that 0 value, but it's never touching it. And I could do the same process. I can go way out here, and you'll notice that it never quite gets there. It's still negative 0.14 here. So anywhere where I go there, it's gonna keep getting closer to 0, but it will never get there. So the process for that one is exactly the same. So we would have the exact same answer for step 3 here. Alright, so if I look at step 4, then it says if it does does graph of y equals 10 over x ever intersect the x-axis? Well, we've kind of already explained that with 2 and 3. The answer to that is no. But the question is why? Why doesn't it do it? Well, let's look at our equation, 10 over x. There's no number that I can put in for x that would make this whole function equal to 0, because the top number is 10. And no matter what, if I put any number in and divide 10 by that number, I'm always going to have some number available there. So if I look at my answer here, when I write that answer out, I'm just going to say no, because 10 divided by x can never be 0. Therefore, when I graph it, it's never going to intersect that x-axis. Okay. The other portion of the activity asks us to look at it from the standpoint of getting closer and closer to 0, and you'll notice as it gets closer and closer to 0, it approaches x equals 0, but never gets there. Okay. Well, what that means is that both of these are lines. Both of these, meaning the x and y axis, x equals 0 and y equals 0, are both lines that the curve approaches but never touches. Okay? So let's take a look at activity 2 now. So if we look at activity 2 then in the chapter, you'll see I have it shown here. In this activity, we're just going to change the bottom value. Instead of it being x, we're going to change it to x squared, and we're going to take a look at what happens in that scenario. So let's come over to our graph now and let's just make that change. So instead of x, let's change that to x squared. And you'll notice immediately what it does is it takes the graph and puts it in the first and second quadrant instead of the first and third quadrant, which would kind of make sense because no matter what number I put in for x here, other than 0, which we're going to find out here in just a second, any other number that I put in for x would give me a positive value, because when I square it, I'm going to get a positive number, and a positive divided by a positive is a positive. So all my y values should be positive values. So here's what that looks like. And once again, if I trace it as I go out, it's going to get closer and closer to 0. Although it says 0 here, it's actually not. You can see that as I roll in on it. If I get much, much closer so you can see, because it's going up so fast on the bottom, it's hard to tell. But now as I get really tight on it, you can see, hey, that's not quite 0. It's negative 0.0047 something. Okay, we're rounding that off. That's why it's so close to 0 that it was effectively written as 0 from the calculator standpoint, but it never actually gets to 0. Okay. Now we can do the same thing on the other side, on the negative side. So if I look at it from a negative standpoint, over here it's going to do exactly the same thing. And once again, it's going to go up this way and approach the y-axis and never touch it as well. Okay. So just like the other one, that x and y-axis represent lines that the curve approaches but never touches. Alright, so then here's the answers then to that activity 2 there. Make sure you have those on your notes when you come to class next time. Alright, before I take a look at some of the properties of those two curves, let's talk a little bit about some vocabulary that we're going to be using as we talk about them. First of all, the name hyperbola refers to the name of a graph that's of the form y equals k over x. An inverse square curve is the same thing except for y equals k over x squared. So hyperbola is one graph, the other one is the inverse square curve. The branches of a hyperbola are the two separate parts of a graph of a hyperbola, and we could say the same. There's also branches of an inverse square curve as well. The asymptotes, really important term for you to understand. When I talk about an asymptote, I'm talking about a line. So an asymptote refers to a line that a curve will approach, but it will never touch it. So if I'm thinking about the graphs that we just looked at, the x and y axis, okay, the x and y axis, in other words, y equals 0 and x equals 0, would be asymptotes for both of those curves, both the inverse square curve and the hyperbola. Okay? And then the final thing is the idea of a discrete set. From your standpoint, a lot of times you want to just think about a discrete set as being something that's non-continuous. There's gaps between the points. The definition of a discrete set is the following, so make sure that you get that down. But you can think of a discrete set as being individual points that are not connected. Okay, so here's an example of a discrete set down here. All of these values are ordered pairs that satisfy a given function, but they're the only values in that function. So we would not be connecting these points. It's those individual points alone, and we do not want to connect them. Okay. The last thing I'd like to do is just take a quick look at the little bit of the properties of each of these curves. So if we think about the curve y equals k over x, a hyperbola, we say that its y varies directly as x. We know that if k is greater than 0, then it's going to be in this first and third quadrant. So first quadrant, third quadrant. And here, if it's less than 0, it's going to be in the second and fourth. So when k is less than 0, it's in the second and fourth. You should know the domain and range is x not equal to 0 for the domain, and this would be, I would just change this to y not equal to 0 for the range. And we know that the asymptotes are the x and y axis. Or you can think of that just like I had before, x not equal to 0 and y not equal to 0. Similar as we think about the inverse square curve, it's called the inverse square curve. It's y varies inverse is the square of x. First and second quadrant if k is greater than 0 here, and if it's less than 0, it's in the third and fourth quadrant. And then we have the domain and range listed. Domain is not equal to 0 for both of them, and then the range would flip-flop depending on which one you're looking at. Okay, so asymptotes, once again, the x and y axis. Another property that we should recognize about this is it's reflection symmetric over the y axis. Okay.